Okay. So, yeah, now we've begun recording. So, a couple questions on the new quiz that is due Thursday, and it's on that 5 minute video on the temperature control. A couple questions might seem like, well, I didn't really, Kifeng doesn't talk about them in the video, and only by looking at the video would you, reading between the lines, would you kind of see what's going on? And two of the questions are basically, just asking you to guess. Like, for example, there's a thermistor, which is a temperature sensor, and it's, put in uh, near where the laser is. And you'll see where the location is. And so one of the questions is that, why do you think it's put in there? And why not somewhere else? um, and it's kind of jammed in there close to the laser diode. And so it's asking you, why do you think it's there? And I'm asking you to take a guess. And just take a guess. You're not going to be penalized too much. I mean, it's just 1 point, I think, for taking a guess. If it's a valid guess, then you get the point. And I'll tell you the real reason if you missed it. If it's all you have to do is make a reasonable guess. And then there's one other question I'm forgetting right now, which again is, yeah, I mean, like, there's something called a set temperature and there's something called a free running temperature. And so, Kifeng chooses a set temperature where the laser will lock, where he wants the laser to lock at. And so once again, I ask, why do you think he does that? And I'm asking you to take a guess. I don't expect anyone to get it, but if it's a reasonable, like a logical guess, then fine. If it's not on that particular question, I mean, I just want you to take a guess. As long as it's not totally like unicorns and fairies, then I mean, you'll get the 1 point. Um, okay, and if you have any doubts, just ask me. I'm stuck by my computer 24/7. Honestly, it's beginning to wear me down a little bit. But besides this class, I had a 9 to 10 WebEx meeting with my lab guys, who are working in the lab actually all through this, Kifang and Alex. And then at 6 to 7 today, I have another WebEx meeting with the younglings that I was training for research. So I mean, there's like 3 meetings in a day, and and honestly, I mean, being stuck on a chair while talking, it's kind of, I like to have my three meter sticks with me and brandish them and sort of my XYZ axes and polarizations and all that kind of stuff. I just can't do that with this. So at any rate, um, any comments or questions before we start today? Anything? Any comments about life?
Wackio.
What's that?
Life's wackio.
Life's wacky. It is wacky at this moment, yeah. And we're kind of all stuck a little bit. But and I don't know how to sort of jazz it up. But hopefully you're learning uh, some nice things as we go along. I mean, what else? What can we do?
You could wear a funny hat next time.
Okay. The shine is too much for you to bear. Like I'm sitting right by my window, and outside in front of me, it's a nice view. I mean, it is kind of my neighbor's house, but there's trees and stuff, and so every now and then I just look at all of that and feel better. Um, I do go running at what's that trail? Um, what's the name of that trail, Amritesh?
Do it.
Do it, yeah, do it. I go running at Do It's usually around 4 o'clock, so right after class. That feels good. But other than that 1 hour outside, I'm not really doing a whole lot because I'm stuck by the computer. And yeah, okay, I don't have funny hats. Plus, my head gets really hot if I wear a hat. But I'll look for a T-shirt. Today's T-shirt is nothing much to comment on. Okay, well, I hope that you are now that I've spent 5 minutes just gabbing. I think and we are recording, so let us start with where we were last time, and you will recall. And let me just move this. I think this might be in your view also. Let me move this over to the side. I don't know if you had it in front, but anyway, there was a dialog box there. All right, and so what we were looking at was a model for a two-level atom, 1 and 2, and it was being driven or excited by this this photon flux sigma phi. Okay, and actually it's just the phi that's doing the exciting. The sigma is what actually ends up getting absorbed. We don't need to put that on there. So it's the phi that's pushing it around. And then we wrote down equations for the population density in the level 1 and level 2. Okay, both those equations are here. And we saw that the population density in level 1 depends upon the population inversion. This population inversion is very crucial because the gain is defined as the absorption cross-section times the population inversion. And if as in a usual situation, normally you expect more population in level 1, right? Because of Boltzmann. Remember Boltzmann's distribution? Boltzmann distribution says that it's distributed as exponentially, right, with the energy. So Boltzmann distribution, do you recall that the energy, the particles are distributed as e to the minus the energy divided by kT? Does everyone recall that? Yeah? And there is some constant here. And so, you expect, so it's proportional to this. Okay. Now, one thing is that I don't see any, everyone's on. I see Casey, I see Ian, Mike, Rosie, Scott, Castle, Chris, Neil. Okay, so almost everyone's here. But of course, and that's fine. Like everyone's video is off. Plus, maybe people are muted, and that also is a good thing to do. You want to unmute when you say something. But I'm hoping that everyone's with me, and I'm counting on you to speak up. Okay, if there's any issue. So so normally you would expect that the higher energies will be exponentially less populated. So normally the N1 is what you expect to be more than N2, in which case this is a negative number. And then we showed that in that case, this is not a gain. It's the opposite of gain. And it is actually what we were calling the attenuation coefficient. Remember in Beer's law, it showed up as the attenuation. But the opposite of attenuation is gain. And so creating a population inversion is very important. All right. So that's where we were with all this. And let us now push forward and see what we can get out from this simple model of a two-level atom, being... Hey, yeah, say it again.
Oh, hey. You go ahead.
Oh, okay. So am I fine?
Is Wi-Fi doing okay? The screen is incredibly laggy.
Oh, for me?
Yeah, your face is fine, but the screen of the notes and stuff is very laggy.
Okay, I haven't really done anything yet, but let me maybe let me try quitting some things here, because maybe there's a whole bunch of stuff that's gotten activated, and sometimes it can have an effect, though I don't see why. But okay, so now let's see if this works. Okay, so I'm going to, and you let me know, Casey, if anything's wrong. Are others also noticing an issue?
What?
Yeah, I think we're all seeing it.
Yeah, that's all.
Yeah, we all are.
Oh, so it is very laggy.
Yeah.
Now I can't tell any difference here. So as I move my hand around and as I write, I'm making mock writing motions, still laggy.
If you're moving at all right now, we can't see it.
Oh my God. Okay. Well, then the only option there is for me to. I'm going to stop the recording, and I'm going to restart my computer. So I will invite you back in about, this will take about 3 minutes or so. So let's just meet up back at like 2:32 or something, like 5 minutes from now, all right?
Okay.
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 Okay, so give me a moment.